Hi, in today's video, we'll have a look at two-sample t-tests. So in many cases, we want to determine whether two samples are statistically different from one another in terms of one characteristic. For example, we may want to know if the average age of male slaves recorded in the Louisiana database is significantly different from that of female slaves. So the null hypothesis that we would set is H naught is that the mean for males is equal to the mean for females. And the alternative hypothesis is just the opposite of my null hypothesis. In other words, that mu male is different from mu female. Okay? So another way in which we can reformulate these hypotheses is as follows. So I just put the mu female on the other side, and so I get mu male minus mu female is equal to 0. And the alternative hypothesis is that mu male minus mu female is different from 0. So thanks to the central limit theorem, we know that if we assume that the null hypothesis is correct, then x bar male minus x bar female will have a mean of 0, because this is exactly what we assumed in our null hypothesis. But we also know that the distribution will be normal. Okay, so with mean 0 and variance, sigma squared male divided by the sample size for males plus sigma squared female divided by the sample size for female. And the reason why we have this variance is because if x and y are independent, then the variance of x minus y is just equal to the variance of x plus the variance of y. So here, if we replace x by x bar male and y by x bar female, we get that the variance of x bar male minus x bar female is equal to the variance of x bar male plus the variance of x bar female. And last time, we saw that the variance of x bar male would be equal to sigma squared male divided by the sample size for male. Okay, and similarly, the variance for x bar female will just be the variance for the age for the female sample divided by the sample size for female. Okay, so this is what we have. So then for simplicity, let's just assume that sigma squared male is equal to sigma squared female is equal to sigma squared. Okay, so the variance in the age variable is the same for males and females. So I can simplify a little bit my formula, and I get that x bar male minus x bar female is distributed normally with mean 0 and variance sigma squared times 1 over n male plus 1 over n female. Okay, so I standardize my variable, so I subtract the mean, which was 0 in this case, divided by the standard deviation. So I just take the square root of this. So the square root of sigma squared will give me sigma, and then the square root of this term will just give me that part. And I know that this will be distributed normally with mean 0 and variance 1. Now, exactly like last time, in practice, we do not know the value of sigma, and we therefore need to estimate it. So once we replace the population standard deviation sigma with the estimated standard deviation s, we obtain the test statistic that we refer to as the t-test statistic. Okay, so the t is exactly like before, x bar male minus x bar female divided by s instead of sigma times the square root of 1 over n male plus 1 over n female. Okay, so it's just x bar male minus x bar female divided by the standard error of the difference between x bar male and x bar female. And this t statistic follows a t distribution with a number of degrees of freedom, which is equal to n male plus n female minus 2. So this is just your total sample size minus 2, because now we estimated 2 statistics. Okay, we estimated x bar and for males and x bar for females. Now, in practice, like for the one sample t-test, Stata or any statistical software will take care of all the calculations for you. But it's good to know what is happening in the background. Okay, so this is how you would conduct a test when you want to know if for two subgroups you have the same mean. Okay, and the rest of the process would be exactly the same as before. So you would need to calculate your p-value and then compare it to your significance level. So that's it for today's video, and I'll see you in the next one.